The year was 1620. A Swiss watchmaker named Jos Burgi wanted to find a more efficient way to multiply large numbers. Burgi wasn't just an ordinary watchmaker, he was also the instrument maker of a royal observatory and is used to doing a lot of mathematical calculations, especially multiplications of numbers with lots of digits. Because there weren't any calculators back then, people had to count everything by hand, meaning that it would take a long time. Burgi then thought of an idea that would help him do this more efficiently. This was his idea. When multiplying powers of 10, you can simply count how many zeros there are in each number and add them up. This would be the number of zeros the result has. Now, what if this very method can be applied to every other number? Burgi then formed tables like these, where you can simply add numbers in the left column to multiply two numbers with the same base on the right column. Around the same time, British mathematicians John Napier and Henry Briggs also came up with similar tables and were the first to name this concept logarithms, which is what we know it as up until this day. But why exactly do we have to know about logarithms? What's the point of even studying them in school? In this video, we will go through 3 different real-world applications of logarithms. Okay, so let's first talk about interests. But what even are interests? So basically, when you deposit money into your savings account in a bank, you will receive something called an interest. An interest is basically a certain amount of money you earn periodically from a bank when depositing your money in your savings account according to a predetermined interest rate, which will often range from 0.01% up to 5% depending on your location. For example, the interest rate for the Bank of Indonesia is 2.75%. This would mean that when we invest 1 million, we will receive 2.75% of that as interest, which we can easily count with this equation, resulting in 27,500. Now here's the thing, there are actually two types of interest, simple interests and compound interests. Let's go back to the example I gave before. Suppose that you receive interest monthly. When you receive the interest, you can either withdraw the interest you receive for you to use or reinvest it along with the principal amount deposited in the first place. The former is what you call a simple interest, while the latter is what you call a compound interest. Let's compare the two with the example I mentioned before. In the first month, we will receive the same amount of interest for both, namely the 27,500 we got before. However, for simple interests, the money will be withdrawn for use, which leaves 1 million in our savings account, while for compound interest, the money will be reinvested instead, meaning that there will be 1 million plus 27,500 in our savings account, which is 1,027,500. The next month, we will receive 2.75% of the money in our savings account, and as you can see, we will earn more for compound interests compared to that of simple interests. You'll see that every month, the compound interest we earn will increase, while the simple interest would stay the same. This means that for simple interests, we will earn less money but be able to receive money to spend every month, while for compound interest, we will earn more money without receiving money until we withdraw the money from our savings account. So how are logarithms even related to any of this? Let's focus on compound interests for now. Suppose that we have 500,000 right now and we want to purchase something that costs 1 million. To gain 1 million, we could deposit the 500,000 we have into a bank to earn interest, like the Bank of Indonesia. We know that the interest rate of the bank is 2.75%. So suppose that this interest is compounded monthly. How long would it take for our 500,000 to turn into 1 million? This is the formula we are going to use to calculate compound interests. A is the total amount of money we will receive when we withdraw the money. B is the principal amount or the amount of money we deposited in the first place. I is the interest rate of the bank. And finally, T is the number of times the interest is compounded. Going back to the problem before, we want to find how many months it would take for us to get the 1 million, which is basically T in this formula. Now, to solve this problem, we can simply use the formula earlier and substitute A with the amount of money we want to receive, which is 1 million, P with the principal amount, which is 500,000, I with the interest rate, which when converted into decimal form will be 0.0275. We can then divide both sides by 500,000 to simplify the equation and do the simple addition, which would leave us with this. Now we can add log to both sides, and because t is an exponent, we can then use this rule and move t out of the log. Divide both sides by log 1.0275 and we'll finally find out what t is. We can use a calculator to calculate this, which would give us approximately 26 as a result, which means that it will take about 26 months or 2 years and 2 months to get 1 million. Now let's talk about earthquakes. Earthquakes are probably something most of us experience at least once in our lives, especially here in Indonesia, being somewhat of a common occurrence with about 1,000 earthquakes happening every year on average. If you have ever heard of earthquakes that happen, whether it's from the news or by simply looking them up on Google, you've probably heard of something called the Richter scale. The Richter scale is a scale which is used to measure the strength of an earthquake, where the larger its strength, the larger its magnitude will be. For example, According to the Richter scale, the recent 2021 Java earthquake had a magnitude of 6.0 according to the Richter scale and killed 10 people and injured 104 people, while the 2004 Indian Ocean earthquake, which triggered the Aceh tsunami, the deadliest tsunami in recent Indonesian history, had a magnitude of 9.1 according to the Richter scale and killed over 220,000 people. So what does logarithms have anything to do with this? You see, unlike other units of measurements like distance or mass, the Richter scale is a logarithmic scale, meaning that the magnitude of the earthquake gets multiplied instead of added as it increases on the scale. In this case, an increase of 1 unit on the scale will mean that the magnitude of the earthquake is 10 times stronger. Now let's go back to the two earthquakes mentioned before. With the use of logarithms, we can know how much stronger the 9.1 magnitude earthquake is compared to the one with 6.1 magnitude. Suppose x represents the answer we are trying to find, which is how much stronger the magnitude of earthquake 2 or M2 is compared to that of earthquake 1 or M1. To find x, we can use the expression below. We can then substitute both M2 and M1 with the magnitudes of the two earthquakes and subtract it, which would leave us with 3.1. Now we know that log x is 3.1, which also means that x is 10 to the power of 3.1, which we can further expand to 10 to the power of 3 times 10 to the power of 1 over 10, and can be further simplified to 1010 root 10, or about 1259. So this means that the 9.1 magnitude earthquake is about 1259 times stronger than the 6.0 magnitude earthquake. Now let's talk about the last application we're discussing in this video, which is population growth. So what does logarithms have anything to do with population growth? You see, a population tends to increase in an exponential function. This is simply because of the fact that people can reproduce infinitely, meaning that increasing the number of births would increase the population, which would then increase the number of people able to give birth, and so on. This is especially the case in countries with high birth rates such as these, where every woman would give birth to up to 4 to 6 children on average, which is why when you Google the population of these countries, you will see that their graphs are extremely steep, which implies that the population increases in a faster rate as time passes. Now, going back to the question before, what does logarithms have to do with any of this? Let's take Indonesia for example. As of 2020, Indonesia has a population of approximately 273.5 million people and is currently the 4th most populated country in the world. When will Indonesia reach a population of 300 million? Obviously, we'll never know when exactly this would happen, as it is impossible to predict the future. However, with logarithms, we can at least give a rough estimate on when this will happen. But before we do that, we have to find something called a population growth rate, which is basically how much population grows from one year to another. To calculate a population growth rate, simply divide the increase of population from one year to the next year of the initial population and multiply it by 100. In this case, the population of Indonesia in 2019 is approximately 270.6 million, meaning that we can first subtract that from 273.5 million, which is equal to 2.9 million. Then we can divide 2.9 million with 270.6 million and multiply it with 100, leaving us with approximately 1.1%, which is the population growth rate in Indonesia in 2019. We can then use this to estimate when Indonesia's population will reach 300 million by simply using this equation. T represents the answer we are trying to find, which is the time for P1, which is the initial population, to reach P2, which is the population after T years have passed, whilst R is the population growth rate. We can then substitute P2 with 300 million, P1 with 273.5 million, and R with the population growth rate, which when converted into decimal form would be 0.011. We can then simplify it by defining both sides by 273.5 million and then doing the simple addition. After that, we can add log to both sides, and because t is an exponent, we can then use this rule similarly with the one for compound interests and move t out of the log. Divide both sides by log 1.011 and we'll finally find out what t is. We can use a calculator to calculate this, which would give us about 8.5 as a result, which means that Indonesia's population would reach 300 million 8.5 years from 2020, which means that it will most likely happen more or less anywhere from 2028 to 2029. So those are 3 of the many ways of how logarithms can be applied in real life. Hopefully, these examples could at least give you an insight on why logarithms and even maths as a whole is important in real life. Thanks for watching and have a great day ahead.